Up on the workbench tonight I have a Panasonic LCD TV. Press the power button. Nothing happens. Okay, we got a light this time. Okay, we actually got the set on. After I don't know how many presses of the power button there, it actually came on. Turn it off. Turn it back on. Again, nothing. Well, this time it's going to come on. Looks like. This time it came on. Turn it off. Turn it back on. Nothing. So they appear to have a slow turn on, intermittent. Sometimes it'll turn on, sometimes it won't. Off. Oh, this time it's going to turn on. And that's the complaint. Sometimes it turns on, sometimes it doesn't. Let's try it with a remote control. So I've now got the remote control. This time it looks like it's going to turn on. What it was doing in the customer's house was the power light was just blinking, and I'd have to turn the thing off and on like half a dozen times. I'd hear it click and it would just sit there with the power light flashing. So I'm see if it's going to do it for me now. We'll get the back off this thing and see what's up with it. So in light of this TV working when it wants to work and not working other times, I'm thinking that we maybe either have lost one of the voltages, or we may even have a bad connection somewhere, either on the main power supply here, or this is the standby supply, I believe. On this one, our 5-volt supply is generated for the remote control circuits, and the main power supply is controlled from a control signal over onto this main power supply. I don't have any paperwork for this one, so let's just probe and see whether we can find some standby voltages. So there's nothing on any of these pins so far. Okay, 3.2 volts here. So we have a 3.2 volt supply, and I'm wondering if maybe that's a switching control voltage. So let's just hit the power button and see what happens. And that's exactly what that is. You notice that went to 0 when the set turned on. If I turn the power off, so that line here, which is on this top connector up here, it's the 4th pin over. So where we're testing here, we're testing the 4th pin on this connector at the top. That pin is the signal line that turns on and off the main power supply. So if that signal didn't switch, I'm wondering whether if for example, if it didn't get the signal to turn on, whether we would see that flashing light that we were getting before. But definitely we have a control line here, and it's 3.2 volts when the set's off. Press the power button. Now the set turns on, but this has not changed state yet. The set's booting up, and it calls for the power supply to turn on, and then the lamp driver turns on. The lamp driver is actually on this board over here, as is the main supply for the TV. So I would expect that we'll probably see some other voltages come back from there. These ones are all 3 volts now. There's a 12 volt supply. If I turn it off, you'll see that we have nothing. If I turn it back on, let's just see if there's a delay to get our 12 volt supply back. 12 volt supply has not started because the power supply hasn't been turned on yet. Now the 12 volt supply comes on. And what about on this connector here? 0, 0. The 23 volt supply. These ones are all 23 volts. So I'm going to say that the 23 volt supply is probably, one of these is going to be the supply for the turn on the backlights, and one's going to be the supply for the TV. So let's just try disconnecting this plug and just see what happens. So by disconnecting this plug, this is the 24 volt supply that's coming back to the other board. We'll turn on the set. I just want to see whether we run into the same symptom that I had before. Just kind of a way of isolating what's going on. Okay, I've now got my exact symptom. I'll show you. This is what was going on. So now I've narrowed this down. This is what the TV was doing. I'll show you. When I got the TV in, now we reconnected our plug, reconnected our power, our 23 volt supply is back, and the TV will turn on. TV goes off, our 24 volt supply drops. TV turns on. Our 24 volt supply comes up first. It's interesting to note that our 24 volt supply comes up before the 12 volt supply. I turn it off. The 12 volt supply is delayed, you notice? And then the 12 volt supply comes on. You'll hear the relay click. If I turn it off, if I go back to this pin here, as soon as that relay clicks, you'll see the 24 volt supply come on. And there you go. So what's happening when you hit the power button, the relay over here is applying 120 volts DC. Here's our rectifier here. To our main power supply, which is developing the 24 volts, sending it back to the set Once the set initializes, it is then supplying a signal back to turn on the secondary inverter, which is for the lamp drivers. I think that's how this one's working. I don't have drawings for it, but from what I can see, that's what's going on, is that the standby supply is here. It's supplying a 5-volt standby voltage for the remote control circuits. And that turns on this main power relay, which through the bridge rectifier sends rectified unfiltered power over to the inverter board. As I don't see any main filters on this, I just see a rectifier. Our main filter is right here. This is the hot side of the circuit. So we're rectifying AC to DC, sending our DC but unfiltered supply over here. It's going in through the main filter, running the power supplies, which are delivering our 24-volt supply back to the set via the interconnect cables. Once the microcontroller is happy that everything's up and running, it then sends a signal back by taking this 3-volt line to ground. See, it's on 3 volts. Once this 3-volt line goes to ground, that is when the inverter for the lamp driver starts. So if we watch it, the set turns on, it clicks on. It hasn't switched on yet. And as soon as that switches on, I see the lamp come on. What I'm thinking, the problem we're having with this set is we're somehow missing a voltage. When it's turning on, one of the voltages is missing. It could be as simple as a bad ground, or it could be a bad connection in here. And I think what's happened on the set is, in the process of taking it apart, whatever was causing it to not start has corrected itself. Could be a bad solder connection, could be just a bad plug. But just the nature of just taking the set apart, I corrected the problem, because it certainly was doing it before I opened the set up. Now, knowing how bad Panasonic has been in the past for grounding screws which aren't tight, let's just check these screws here and see whether they're tight. Well, they're not. They're really not. They're not tight. So this problem could be just loose grounding screws. I'm going to pull this board out and just take a look at see if there's anything obvious on this board that's causing a problem. But I think I've narrowed the problem with the set not starting down to a problem on the power supply here. It could be a feedback problem between the two boards. The voltages aren't being correct. Well, one thing that's certain, a set of these connections down here on these connectors that connect to the power supply and the main board don't look to be perfect. I'm using high magnification, typically my good old TV camera lens that allows me to inspect these connections very, very closely, and some of them do not look to be particularly well soldered. So I'm going to go and reheat these connectors here. And here's the main power supply board, and this one here, these connectors here even look more questionable under high magnification. This one right here, third down from the end, looks like it's cracked all the way around. Yeah, I think this is where our problem is going to be. It's right here on this connector, to tell you the truth. just looking at the quality of the solder work here, I don't know how well it shows up on camera, if I can get in there any closer or not, but I guess it won't go in focus any closer than that. But I don't know if you can see it with the lens here or not. But I mean, some of that solder here doesn't look to be great. Let me see if I can get the light on there, and maybe you can see it a little better. You see that? It just doesn't look good, and the camera doesn't do it justice. But looking at it with the eyepiece, this one here, 3 down from the end here, looks to be cracked all the way around. I think that's where the problem on this is going to be, is there's going to be a bad connection, and that's what's causing this set to go intermittent. And it would make sense, because that's typically where you have a cold solder connection, and depending on the temperature as it heats up, right, it either makes or breaks a connection. Just move the set, you know, any flexing and so forth from transporting it, any flexing of the board can certainly correct or cause problems if there's a connection that's not done right. So it's going to go over this entire board, take a close look at it with the magnifier, and resolder all the ones that look to be a little bit questionable, and we'll see if that gets us set up and running. Well, now that I've resoldered these ones, I think a little better now. Yeah, I'm not seeing any cracks on them now, so hopefully that's all it was on this thing. And again, it could be loose ground screws too, because these weren't, the screws that hold this board in also weren't particularly tight, which seems to be a common problem with Panasonic, is that some of the ground screws aren't tight enough, and as in the case of their plasma TV, it caused the board to fail. I have another plasma set myself. My studio TV has started to act up a bit. I'm going to have to do a servicing on it, and I'm sure it's probably going to be the SS board connections are all weak on it. It hasn't blown up at this point, and I really would like to catch it before it goes kaboom, so we'll probably be doing a service video on that one in the not too distant future while that set is still functional, and see whether it is just the SS board that is failing, or I should say the screws, because if you remember from the 50-inch one that I did a while back there, the SS board failed after some grounding screws came loose, and the replacement parts came with some lock washers and new screws to prevent the screws from coming loose and causing a repeated failure. So that is a problem on Panasonic plasma TVs. This one's an LCD TV, but you know what? If they're having a connection problem that's causing problems on their plasma TVs, then chances are the LCD TVs have got the same problem. So we're just going to remount this board, remount the other board, and then we'll test this set and see if it's working. Basically, the job of this board, this is the main power supply, so how it works, I was connecting, these are the high voltage connectors for the fluorescent lamps. And how it works, this is the standby board. So your 5 volts is generated on this board. It's passed over to the set by this connector, which powers up the CPU. When the set calls for power, it energizes this relay. When this relay energizes, the 120 volts is rectified from AC to DC through the bridge rectifier and passed over through this connector to this power supply. As soon as this power supply receives power via this power connector, it turns on, generates 12 volts and 24 volts back to the set here, back to the set via this connector. Once those voltages have stabilized, the CPU says, okay, I'm happy, everything's working, let's turn on the back lamp. It changes the 3 volt signal to 0 on this connector, which feeds back to this panel, which then turns on the inverter for the backlight. That's basically in a nutshell how this thing works. So let's get the standby supply remounted so that we can test it. What a lot of the manufacturers do is they cheap out rather than going to a multi-layer board so that they can have a continuous ground. There are sections of the board where it's physically impossible to run a ground from one section to another. Now, what better manufacturers do is they'll either have a double layer board and they'll have their ground connections on the top side or on a multi-layer board, or they'll put jumper wires in like this to carry the ground from one section of a board to the other. And then other manufacturers, they don't bother. They just ground the board in multiple places. So they'll ground it to the chassis here, they'll ground it to the chassis there, they'll ground it to the chassis down here, and they'll actually use the metal chassis as the ground. And Panasonic is one such manufacturer that does that. It's not the best practice to do because all it takes is the ground screw to come loose and you've lost ground to that portion of the circuit board. And that's what happens on those plasmas like the one that I had to repair. And what's happening in my studio set is that one of the screws has worked its way loose, that it supplies ground for that section of the board, and that grounded circuit is unbonding from the ground, which can cause voltage fluctuations, and in the case of the plasma set, can cause it to blow up. So we've got the power connectors reconnected here and the power cord, and we'll turn it on and see if it works. And there we go. It's going to show first time setup because the power has been removed. So I'll just take that off the screen by pressing the return key. And what we're going to do is we're going to let this set test run and make sure that everything's good. Keep my fingers crossed that it will continue to turn on every time I turn on the set. We won't have that problem with the flashing power light anymore. Now, in these sets, while we're on the topic of ground screws not tight, check out these ones here. Look at this. Okay, that one's loose. And this one here. That one's not so bad. How about this one down here? You know, these are not very tight. And that was another one that's really quite loose. So, I mean, I'm just going to go tighten up all these screws that are used for grounding. Especially the ones that have got a tab on. That one doesn't have a tab on, so that one's probably not going to do anything. I think that's just the extra set of inputs. But any of these ones that have got a tab on them, like this one up here, this is a grounding screw. And that one wasn't too bad. But some of them are really quite loose. It's a recipe for disaster, folks. If you find loose ground screws, snug them up. Now, I'm not saying tighten them up so tight you're going to break the circuit board, but you know what I mean. Snug them up so that there's no play in them and that they're at least somewhat tight. You'll avoid a lot of headaches by tightening up loose grounds. It was a very common problem throughout the years of my servicing career, ground screws coming loose. Very common problem. It would cause, sometimes it would just cause intermittent problems, other times it would actually cause components to blow. So when you find loose ground screws, tighten them up.